Welcome to the Intellectual Anarchy podcast. I'm Patrick Sullivan.
And I'm Catherine Cruz, and I'm just a curious cat.
Well, groupthink is this interesting condition where people play off of each other and convince themselves of the condition of something, the limitations of something, or the idea that there's only one way to think of something. And there's really good examples out there, but one of them I like to look at is Rochester, New York, where Kodak created this incredible business around film and chemical processing of film, which was an amazing business. And the fact that they developed a digital picture and digital camera, but the people there dismissed it because, of course, they own the franchise, they own the space, they own how everything is done. So digital photography was really developed more on the West Coast, but it was invented right there in front of them. That happens a lot, actually. So you've got these companies now where they've kind of lost their mojo. Like there's a really interesting article recently on 3M. 3M used to be this prolific innovator. Now they're a Six Sigma kind of quality outfit, which is important on the manufacturing side. But in some ways, they've lost their mojo on how to create new things.
They got too comfortable.
I was just at a meeting with the folks at the Smalley Institute at Rice University. And Smalley got the Nobel Prize along with these other two folks. We had one of them here, I think Harold Croteau, around carbon nanotubes and nanotechnology. That was a big deal. And so we were talking there at Rice, and now they have lots of money, beautiful labs. Everything looks really good, but they're worried about their mojo because when they were innovating, it wasn't scripted. It was kind of messy and edgy. People shared labs, they shared space. They banged into each other and had conversations that totally off subject. You know, it wasn't scripted. It was, you could call it serendipity, but it was really, I think, scientific improvisation. Improv is how you build on each other's crazy ideas. And so that's really what led to that, which became the Nobel Prize, which brought all this interest and excitement. They created the Institute. But now they're looking at, like, how do they get their mojo back? And I was telling them, we don't have the same problem here because we're always undercapitalized. And the people bang into each other in the lab space. We're redoing the labs. We have more lab space, but we don't want to lose that edginess. And so the idea that there's a little discomfort and it is suboptimal in terms of if I have this perfect lab, then I'm going to do perfect science. The fact that it's messy actually creates, I think, a better environment for innovation. But it's a little counterintuitive because it creates that environment because it's people banging into each other who don't have any necessarily project in common. They're just talking story and sharing ideas. So when really interesting ideas happen, it's usually off script, right? And that's, I'm sure, that related to the same issue at 3M. But you can see how that happens where, like with Kodak, because here they are in the 70s, they had developed a digital picture. And when you look at the first system, it was really kind of kludgy.
Crude, yeah.
But they're saying no one's going to want it, can't work, never going to be efficient, and on, when in fact, it totally destroyed their business because they walked away from that idea. That happens to companies. They get really good at what they do and comfortable in the way they do it, and they have their own groupthink where they think that we own the world, we own the franchise, and nothing's ever going to change. That's usually a big mistake.
Yeah, it's just getting back to the idea of you argue your limitations and they're yours. Like, oh no.
Right.
We're in a good seat right now. We don't need to worry about that.
But
Yeah.
the thing that just came out in the news, so the war with Hamas in Gaza with the Israelis, it just came out that the Hamas plan, the Israelis had it in their hands way in advance. They just said they're never going to do it. They totally underestimated what these guys were able to do, assuming that they were better, superior, better prepared. And that's usually a mistake, right? Underestimating what other people can do. And again, what we learn is that methods and materials change. What was not possible becomes possible. What was unthinkable becomes doable. And so the tools that were not available become available in time. And a lot of those tools may be off Broadway. They may be on the fringes of little labs and people trying stuff out and small innovators trying things and experimenting with things in these kind of the obscure journals in science and engineering where they discover something and they write about it. Maybe it doesn't get a lot of attention, but it builds on itself. That's kind of what the world does. And in the tech space, it goes pretty fast. And so you get these big enterprises that are managing themselves so well that they kind of lose their edge.
So you almost have to be kind of off balance or on the edge of your seat and not just sit back.
Right. You got to be a little bit lean and hungry. You have to want to try stuff and be willing to fail, to experiment, to challenge what you think you know with things that maybe it's different today for reasons that are new. And maybe you didn't know what somebody was trying. So, for example, we're looking at computational DNA. That sounds ridiculous. But this question of how do human brains compute, what's the right model for human intelligence and cognition, but the capacity in a brain and the efficiency of a brain is pretty amazing. What you do with the limited calories you take in and your ability to think, compute, and do all kinds of stuff. So we're thinking we should play with this. And that means try it out, see what we think, probably find little examples of things we can do, simple calculations, for example. But we kind of mapped out, hey, we could design and print these molecules, organonucleotides, RNA or DNA, and make little computers. So we may just try it for the hell of it, just to try it. But it's part of this journey to understand how to build a better computational capability, because right now we just think in terms of silicon wafers. So the world is focused on chips, and chips are really a big deal. So what if there's another way to do computation?
And so at what point, though, do you have to, cut it off? Like, okay, we've explored this. We just now need to go in another direction because we're not getting the results that we want.
And we do this quite often. We try something, and it may be a decade ahead of its time, but we may gain an insight. So we talked about earlier 3D metal printing for these exotic alloys. We've been experimenting in this space for almost a decade. We got some really good early results, but it was kind of too early. There wasn't a market. It just seemed too crazy. There's a category of materials we call unobtainium because they're things that don't exist in the world, and yet we found a way to make them. Now we think there might be a way to produce them at scale, but it's probably a decade later. It's not unusual. So we do these things, and then we may just kind of store it away somewhere because, again, in our case, we've learned that 50% of the risk is market risk. Too early or too late is hard. Trying to get the timing right is really important. And so the way we do that, we manage a portfolio of really cool stuff. And then occasionally we see an opportunity, we may accelerate it or build on it. But we may have already tried it. And so what we're learning is that's not a bad way to do things. So we can explore these ideas, but it may not be the right time for the market, but we may learn something. And so as the market pivots, we might say, hey, that thing we did.
Yeah, it's not totally useless.
It's not totally useless. And so we've got a whole group of people on the commercialization side. They're out always trying to listen to people, talk to folks in different industries. And this time of the year, the fourth quarter of the year, we're trying to ask ourselves, what should we think about? Trying to pick a thing or two. Maybe it's never been done, but we'll take a crack at it. We usually do it on our nickel because nobody would ever fund some of these ideas. But those are the things that will lead to new things. But it's not a straight line. So, if you're trained as an MBA and you're managing all the square pegs and square holes and the round pegs and round holes, this is not your business. But what we're doing is we're trying to find those interesting areas, and then we're trying to manage the portfolio against the market. And when the market's ready, then we accelerate.
We've just come out of the pandemic, and, we just saw some incredible stuff, incredible solutions come out of research that had, been conducted, but just kind of put aside. And then voila, that was it.
Yeah, no, it's a really good example. I think DARPA underwrote the early work in the mRNA. And at the time, I'm sure it just seemed too crazy. So NIH, National Institutes of Health, is generally very conservative. They like to pursue a thing and just keep doing it and doing it and doing it, what we call polishing the rock. Where what DARPA did was they funded something that sounded ridiculous. And it turned out there was something there. They had to solve a really interesting problem, though. They had to build the delivery, what's called a wrapper. And you had these guys at, I think, Pennsylvania State that were playing with or doing this work. And it was kind of this mashup of these different ideas that happened to come together when the pandemic hit. And then it's like, wow, we could take this piece and this piece and this thing and make what became the mRNA vaccine in record time. And it was very specific and effective. That changed a lot of things now going forward. Here we are, a couple of years outside the beginning of the pandemic. Those tools have got everybody thinking about whole different ways to build and deliver therapies for everything from cancer to disease management to you name it, because it wasn't possible before. So now you've got what's looking like a Lego kit. You can put these pieces together, take this molecule, this thing, kind of mash them up and say, let's try this. And that's how that kind of innovation really pushes along. And so that's going on right now in the medical space. But it was underwritten by guys like DARPA, who took a chance on something that probably wasn't even, controversial was probably an understatement. And I don't think NIH or anybody would have funded it at the time. So that's kind of what they do. We do a little bit of that too.
And so, you're basically on a ride, and you're kind of out there, but you've got to know when to pull back,
right.
When to lean into something, shift your balance,
right.
Accelerate, go faster. How do you strike that balance though?
Yeah, it's a hard balance because, as I tell people, at a high level, most companies are built to manage. We're built to innovate, so it's hard to manage. And so managing this is not easy because then you've got to say, okay, let's slow that down and speed this up. And the way we kind of vet it, we may do the science, the basic science, and then we're trying to listen to the market. What's the market telling us? What's the application for the early adopters? We're looking for who are those early adopters? There are people with a lot of pain and no answers. How do they deal with it? And so we try to find those early adopters and then start testing out those ideas with the kernel of the insight we developed. Because the pain in those spaces might be so high, they're willing to take a risk and try it out. And there's really some terrific examples of this, but one that I'm a fan of is what Nikola Tesla did in Telluride with the first hydroelectric plant. Telluride was way off Broadway. Nobody would underwrite this, what at the time was a crazy idea, because I think Edison had focused on DC electricity, and here's Tesla trying out this AC thing with these generators. They did this in Telluride. Turned out it worked pretty well. So they electrified the mine, electrified the town. But it was because they didn't have any really good ideas. They were willing to take a chance, and they were early adopters. So those early adopters show there was something there, and that later became the global standard. There's all kinds of examples like that. But you're trying to find an early adopter. So to your question, how do you get outside of yourself and say, I'm in love with this idea, but there ain't no market? So you've got to go and ask the market. And if the market's not ready, sometimes you put it on the shelf because you just can't do it without some market pull. But finding those early adopters, they're kind of the off-Broadway guys, people that have an obscure thing, and yet it's a big problem for them. So they're going to want to take a chance. And we do that in energy and aerospace, healthcare, industrial applications where people want to take a chance because they're stuck in their own groupthink. So take the oil and gas industry, energy. With the blowout of the Macondo well in the Gulf of Mexico a few years back, British Petroleum, it's like a $50 billion problem, killed people, destroyed a lot of the environment. The well was a runaway mess in the Gulf of Mexico. And when we first started working with those guys, we learned that they're in their own groupthink. And here we're coming at it from another perspective. So our company Corpus is in Hawaii. And we're looking at what they're doing, thinking, well, there's half a dozen ways to solve this problem on cement steel bonding. We actually developed a nano treatment of steel casing to improve the bond strength, which was the mode of failure for that well, by 100%. And then we scaled it up from small samples to a facility in the Gulf of Mexico in 18 months, a factory we built with Shell, BP, and Chevron, I think, collaborating on some wells where they use the steel casing that we treat. And but we're coming at it from way outside the normal groupthink. But that's what made us popular in that space, because we're coming at it from totally left field as far as they're concerned.
Yeah, but I imagine, though, the satisfaction that you're helping to protect the environment.
Right. We were able to demonstrate how to do something in a different way and produced results that one of the folks that we were working with at Shell at the time said they've been trying to solve this problem for 20 years. We come along out of left field and we solve it and we scale it in 18 months. They don't see that often, but see, there's very bright people in that industry, really intelligent, huge amounts of education, but they're only kind of talking to each other. We're talking to people in healthcare, in aerospace and defense, and a whole bunch of other industries. So we're not just locked into that one way of thinking. That's why they like us.
Right. You've got nothing to lose, really.
Well, they were early adopters of an idea. We had developed this particular idea of manipulating surfaces using nanotechnology during one of these, in the early 2000s. We thought, this is a cool area we should look at. Not because we had all the experts around the room, but we said, we're interested in this area. And we learned it. We started doing work in that space. And that's one way we kind of help manage the groupthink problem, because we pick a thing, even if we're not in the business, and we say, that's a really cool thing to think about. We start working on it. And then it turns out we're usually ahead of a lot of people's thinking. And there might be a few universities trying stuff out, so we might find some of those folks. But what we're really doing is trying to think, so how do you really use this? So the first application of these little nano-treated surfaces was with a little internal thing we were playing on water hockey. So you put a drop of water on a surface and you make it roll around the surface because it's super hydrophobic, meaning it repels water. But then we learned that we could make surfaces hydrophilic. Oh, it really likes water. And then we could titrate it into doing oilophilic, oilophobic, all kinds of weird
Just play with
surfaces. We thought, well, this is really cool. So what do we do with it? And, this is where we came from left field, but we were playing with these applications, and that's how we kind of knew how to, we had new ideas.
And did you try it on surfboards?
We did. We tried one experiment by putting titanium nanotubes in a surfboard resin to make it more ding resistant. And it did. It made it like 500% more resistant to dings. It was still very light and performed. It was a foam board, a more traditional design and the way it was built. But the idea there was to punch through this glass ceiling of PowerPoints versus making stuff. Once people knew they could make stuff, then it's kind of no stopping them. Like, well, then I can try this, I can make this, I can make that. Pretty soon, we're making stuff. And because of the lack of hesitation, it gave us a lot of flexibility to try new ideas.
So it's cowabunga, just go for it.
Right.
Yeah.
And so we did before we really found any of these applications we use today on aircraft. And, there's medical, there's all kinds of ways to use nanotechnology. But back then, we just thought it was a cool thing. And so I mentioned Smalley and the Nobel Prize, but his co-awardee, Harold Kroto, was here in the office. And we have a No Limit speaker series. And we asked him to speak. And he passed away, I think, last year or something. But his inspiration for it, he's an avid soccer fan. And it was this curiosity of how soccer balls are really shaped and how they perform. As he talks about it, he was interested in art and soccer. He wasn't thinking about chemistry and nanotubes. But he found this confluence of these ideas, which became the carbon nanotube, the basis of the Nobel Prize that he shared with Smalley. And so they were kind of sharing these ideas from these different fields, but they had interest outside of just the one thing that they might, be paid to do.
Right. So you never know where that little spark
Right.
will come from.
But saying that art and soccer inspires applied chemistry and nanotechnology, see, that's an improvisation. Humans are good at that. And creating the space for that, that's the mojo they want back. We do that stuff here, but that's what a lot of businesses manage out. So you don't get that, and they manage it around groupthink. Here's how we always do it. Here's how we always think about it. Stay in your lane. Here, we give people the opportunity to get out of their lane and paint outside of the lines, within some disciplined approach. So it's not all the time. We still got to pay the bills every 2 weeks, right? People like to get a paycheck, but we give them the space to to do things outside of the norm. And some people love it. Some people are terrified of it. And the people that love it, love being here and doing that. The people that are terrified of it, it's probably not a good fit.
So what do you see on the horizon for Oceanit with 2024? And
boy, there are so many opportunities. Clearly, lots of opportunity in the energy space in trying to everything from addressing climate through things like carbon capture and even these areas around geoengineering, to new kinds of energy, to producing new kinds of fuels or fuels we know about, which are hard to get on scale. For example, hydrogen. We've been playing with this thing using directed energy. It looks pretty cool. We can produce hydrogen in a whole different way. So the energy space is really exciting. So on the one hand, you got solar panels and windmills. Everybody knows about that. But we think there's way more to do in energy. So that's actually very exciting. Aerospace and defense, there's tons going on there. Everything from drones to communication to augmented reality to all kinds of stuff. And so we're working in those spaces. Healthcare is another one. We've got a collaboration we're launching with UH and Queens, who we worked with when we produced our rapid test. I think now we're trying to pencil out how to do therapies for different kinds of cancer and different kinds of disease using the tool set we put together, but working with the clinicians and other researchers and making a HUI or a consortia to try to produce some new therapies in ways that haven't been done before. So that's really exciting. So all that's going on. We're looking at that, and it's pretty cool. So the fact that, for example, we just bought a new machine that'll synthesize organonucleotide molecules, and it's an expensive machine, comes with its own software and everything. First thing we're doing is probably invalidating the warranty by hacking the machine and making it do things that it wasn't built to do, because we got tons of ideas to use it for. Same thing, we're looking at printing metal objects with these really interesting alloys that don't exist, this category we call unobtainium, for everything from hypersonics to supporting space travel. So you look at this, what's going on in outer space. It's not just Elon Musk. You've got the whole world pointing at space and what that means. And so, of course, there's defense and security issues. There's lots of commercialization issues, everything from new energy to new materials to, colonizing the moon, all kinds of stuff. So all that's going on. And so they need new ways to do things. So we've got a project on space armor that we think you can only build it with a printer, 3D printer, but it looks pretty awesome so far. You can take on hypersonic impacts. But it's using biomimetics, which means we're learning from seashells and butterflies to produce things to sustain impact in outer space. It's really cool stuff, but it's a lot of fun. And what I'll be doing is trying to find more young folks to join, looking for young PhD physics, chemistry, materials engineering, artificial intelligence, computer science, to kind of get, join the team. So I'll be out looking for people, and but I'm optimistic. Of course, I generally am an optimist, but it's an exciting time.
Yeah.
The world there's lots of problems, so don't get me wrong. The things in the Middle East, the tension with China, the rampant disinformation, the threats of artificial intelligence, but at the same time, there's just huge opportunities.
Well, good luck with your hiring.
Oh, thank you. But what we try to do then is to, back to the groupthink theme, is to push ourselves outside our own comfort zone and try to see the world differently and see what it tells us. That's the exercise we've been going through.
Okay, groupthink. All right.